than a system of equations, but it's actually less complicated because it's specifically a graphical approach. The only thing that makes it tricky is that you need to get the equations in the appropriate form in order to create the graph. So I'm going to solve each of these for y in terms of x. First thing I'm going to do in my first inequality is subtract the 2x. So I'll be looking at negative y is less than negative 2x plus 3. I like having not only the y on the left-hand side to make it easier to graph, but also the x come first on the right-hand side, so it's in the nice y equals mx plus b form. All right. Then I'm going to take both sides and divide by negative 1. So I'm going to get y is greater than 2x minus 3. All right, it's up to you if you want to graph that first, or if you want to do the algebra, get all the algebra out of the way when you do it on your own. Right now, it's up to me. And what I'd like to do is get the algebra out of the way. So I'm going to subtract the 4x. So 3y would be greater than or equal to negative 4x, which would make y greater than or equal to negative 4/3 x. All right. So y-intercept for my first inequality is negative 3. Slope is 2, so up 2 over 1. Oh, overshot the mark, or undershot it, whatever the right word is. All right. This looks like a reasonable dotted line, but if you're uncomfortable with the look of it, that's fine. You can make it dashed. Some people like to make it dashed to make it a little bit more obvious. The one thing it can't be is solid. So if you left it as dotted, that's fine. If you make it dashed, that's fine. As long as you don't make it solid, you're okay. All right, we'll worry about shading in a minute. Now, I'm only looking for the interval that coincides between the two, because this is an and situation. Put a little and symbol here, going back to the last unit. Now, the other inequality has a y-intercept of 0 and a slope of negative 4/3. So that's telling me to go down 4 to the right 3. And same idea, just going the other way. Trying to remember how to draw a line here. I learned it last time. I just can't remember which function it was. Was it this one? No, that's like a highlight. Maybe it was this one. Try it. Yeah, there we go. Kinda. It's a little off. Well, if it's a little off, just make your points bigger. Nobody will notice. All right, this one's a solid line because the inequality involves an equal sign. All right, so I'm looking for the solution interval. You don't want to go too crazy with the shading. All you want to do is shade the appropriate interval. So I'm looking for the interval that is above 2x minus 3 and also above negative 4/3 x. Which region would that be? Left, right, bottom, top? Top, yeah, right? In between the, if you think of this as a V, it's within the V, because that would be above the blue and above the red. So the part that coincides would be this area here. And because the regions could be pretty particular, just put an S in there. I don't really care about that on a test. And in all honesty, you might look at this and go like all the stuff that the Regents is looking for. You might say, okay, cool, I'll worry about that when the Regents comes. And I'll remind you, right? So if you just want to shade and call it a day, honestly, I'd forget to take off anyway when I'm grading your papers. So you forget to put the S in there, I'm going to forget to do -1 or -1/2. So it doesn't matter. The Regents is not going to forget it, so I'll harp on it then. All right. All right. That's a general idea. Now everything else on this page is just a slight variation of that. So the second system, written in a different form but means the same thing. So we have one that needs to be adjusted, the other is fine the way it is. So first I'd subtract x from both sides. And then negate both sides. All right, we're not going to have any solid lines in this thing at all. All right, we're looking at a less than symbol for the first piece and a greater than symbol for the second piece, so no solid lines. Y-intercept -5. Slope of 1. Here a dotted line is going to be just fine because I don't know how I could make it dashed and have it look any better than what I'm doing as a dotted line. That's me personally, because I'm terrible at drawing. No, your drawings aren't that bad. They're all right. You do a pretty good job. You get the point across, and that's all that matters. I appreciate you saying that. It's very thoughtful. That's really what it's coming down to. All right, x greater than -1. All right, what kind of line would x equals -1 be?
Straight line.
Well, they're all straight.
Horizontal line.
Not horizontal, vertical. All right, the up and down one. All right, so here I don't need points. I can just draw that vertical line, just not solid. This time I'm doing it dashed. Doesn't, oh, wrong thing. And again, I'll say it again, and I think this will be the last time I'll say it this class anyway. The Regents look for one thing and look for something else. The Regents would like you to label these as y equals, and they want equals for some reason, even though it's not equals because it's dashed. But negative x -5 and x equals -1. I don't know why. To prove to them that you know which is which. We do a very good job of separating you in the gym. Like there will be at least 5 feet between you and the next person taking the Regents exam. Like you'd have to actually be able to see through people in order to cheat on this thing. So if you got these graphs down on paper, it's because you knew how to graph them. I'm not concerned with the labeling, but again, down the line, somebody will be, and we'll deal with that when it comes up. All right, so x greater than -1. Well, the x equals -1 was vertical. Am I going left or right of that vertical line? Right. Okay, so you could kind of just look at it as is. The arrow is pointing to the right, so shake to the right. That's a nice case. You know, you don't always get that. When it happens, though, it's very nice. All right, for the red one, am I going above or below?
Below.
Below. So I need to go right of the black line, dashed line, and below the red one. So that's all of this stuff in here. All right. If you're ever in doubt, pick a value. And that's actually where they kind of they sort of try to with Common Core, they try to manufacture common sense. Like they sort of try to get you to learn common sense in a classroom. I don't know that that's necessarily something that's always teachable, but what they would say, if you think to those problems where it's like, test the coordinate 5, 1 and see if it's a solution. That's not really so that you can just plug numbers in and get an answer just to satisfy somebody's curiosity. It's more so that you can verify that your answer is correct. So I think that this purple region here is the correct region. How can I check it? Well, what I can do is I can choose a point that's in that purple region. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll take 10, 0. Plug in a 10, 0. One second. Plug in the 10, 0. Into each piece. And see if it gives you something that's true for both parts. All right, so 10 minus 0 greater than 5. 10 greater than negative 1. Needs to be true for both parts. Is it true for the first part? 10 minus 0 is 10, which is greater than 5, yeah. Is 10 greater than negative 1? Yeah. If it's true for both parts, then the value that you chose works in this system. And that value you chose is in that shaded region that you created. So, pretty safe bet that you shaded the right area. But
Why is it to the right?
because the arrow is pointing to the right. All right. The remaining questions are a little bit easier, even though they have additional parts, with the exception of maybe this guy over here. This one's set up, ready to rock and roll for us. And the numbers are nice enough that they don't really require any scaling. Well, they don't require any scaling at all. I'm going to create a little color coding here, and then probably completely forget about it. I don't know why it defaults to yellow. I don't like the yellow. All right, x plus 4, 1, 2, 3, 4, with a slope of 1. Is this going to be a solid or a dotted or dashed line?
Solid.
Solid. So let me do a solid. Oh, undo. Oh, wow. It's a little out of whack, but yeah, that looks bad. Ooh. Try that with a few more points here. A little bit better. Oh, why does it do that? Oh, because I'm not on that tool. All right. All right, so that's one. The second inequality, you may want to adjust it. If you don't need to, but it's the same as negative x plus 4. A little bit better to think of it that way so that you can clearly identify the slope and your y-intercept. Slope is negative 1 now.
Do we have to label the lines as the solution?
Question for the class. Good question. Do we have to label the lines?
Yes.
See if we've been listening.
No, but you should.
Who wants you to label it and who doesn't care?
You don't care.
I don't care, but the Regents does. So should you?
That was just the S.
Yes, to get in the habit, because somebody who doesn't have a lot to do with their time down the line is going to really care about that. It's just that person is not me. So if you forgot to do it on one of my tests or quizzes, I'm going to forget to take off points anyway, so it doesn't matter. but on the Regents, you're definitely going to want to do it. So if you think that not getting the good practice now is going to hurt you down the line, start labeling them now.
I thought that was just for the X thing.
No, everything.
Oh.
Yeah. I am not a big fan of labels. All right, y greater than or equal to 0. Well, y equals 0 is what kind of line? A horizontal line. Specifically where?
On the X.
On the x-axis, yeah. All right. One other benefit to labeling would be for your own purposes. If you think just for organization, it helps you to kind of see things a little clearer. Not the worst idea in the world. See, I mean, I didn't label it, but I color coded. And by color coding it, I can keep track of things. You know, whatever works for you. I mean, I've had people come into my unit tests and quizzes with a whole bunch of highlighters so that they can do the same thing. Highlight, highlight, highlight 3 different colors and then highlight their lines. That's great. That's perfectly fine for me. Regents, different story, because they only want blue or black ink. So, anyway, below x plus 4, so below the blue, also below the red, but above the green, so in the middle. All right. All right. Just be careful with questions like this, because I've had people walk out of this lesson being like, okay, if it forms a geometric figure, so like a triangle, a square, or something like that, just shade it in. I don't even have to think. I mean, that's the makings of a trick question right there. I could have something like below, 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 or below, above, above, in which case it's not the triangle that's being shaded. So still make sure you read it, but it's kind of fun when it does happen. Math fun, of course. Bless you. Now this one we do have to address a little bit. I'm going to subtract the x. So we'll have 3y is greater than negative x. And then I'll divide both sides by 3. So we get y greater than or equal to negative 1/3 x. All right, so x greater than or equal to 0. What am I drawing there? Vertical line where? Y-axis. All right, y less than 2. What am I drawing there? Smiley face. Picture of a basketball hoop. Horizontal line. Yeah. Where? 2 units up. Yep.
Is it dotted?
Dotted or dashed. Yep. Aww. I think I'm gonna have to freehand this one. Disgusting. All right. Now this one, y-intercept 0, slope negative 1/3, so down 1, right 3. So and one final mirror on this side. And going in the opposite direction, we have a bunch of mirrors. Okay, so now my shading. Right, below, above. Right? I mean, so what is that going to?
Right below.
Right, below, above, and what is that? Where does that put me graphically?
It's between this little triangle.
Between, so from here over?
No.
It's there
From
over
the
to
right.
the y-axis.
From here to the y-axis?
Yeah.
Just this little sliver of triangle?
No.
No?
It's from the line.
Yeah.
Here?
Yes. To the right.
Yeah.
And to the right?
Yeah. I can't go a straight line.
So you're saying all of this?
Yes.
Okay. So let's say I'm not convinced. I mean, I am convinced, but let's say I'm not. I'm going to check. I'm going to check the coordinate 5, 0.
How do you come up with these, like,
I just need a point that's in the shaded area.
oh,
Anything I want. Anytime you can incorporate a 0, that's going to make life easier. So I'm going to put in a 5 everywhere I see an X, a 0 everywhere I see a Y. Is my first sentence true? Yeah. 5 is greater than or equal to 0. Is 0 less than 2? Is 5 plus 3 times 0 greater than 0? Yeah. So it works for all three. So we are pretty satisfied that what we just came up with is correct. Now, if you thought maybe this triangular region was correct, then maybe choose a point that falls in there, like -1, 1, and see if that works. You should get something that's false. If it's false for any part of it, it's out. Okay? If it's true for 2 of them and false for the third one, no good. Okay? All right. So this one should be, sorry, I'll be right with you. Dashed.